Hi, my name is Nicholas Stewart, and I'm going to be giving a demo of Experiment 5. We're going to start by creating figure 5-1, which has two NOT gates connected to an AND gate. The NOT gates are also referred to as inverters. The NOT gate is inside chip 7404. So as you can see, we've placed chip 7404 on the leftmost side, and it's in the center of our breadboard. And also, excuse me, and also we've placed chip 7408. It's hard to see the chip label, but chip 7408 has the AND gates inside of it. We make sure that each chip is connected to both ground, here's our ground, and also connected to VCC, which is our power. This is our VCC. Also in the AND gate, we have VCC and ground. In order to make sure that ground is receiving the ground signal, the ground circuit, I guess, in order to make sure that ground is attached to ground, I take a wire and plug it into the negative section here, and then wire it to ground, G and D. Also, in order to make sure that it's receiving power, VCC, I connect that to the plus symbol and wire it from the 5-volt section over here on my Elenco trainer. Next, I make sure that my NOT gates, my inverters, are connected to my AND gate. So the way I do that is I attach a wire of which one end is connected to the output of one of the NOT gates. That's pin 2. As you can see in the diagram, pin 2 is the output for a NOT gate, and pin 4 is also the output for another NOT gate. So I connect a wire to pin 2 and also another wire to pin 4, and from those outputs I connect them to the two inputs of the AND gate, which are pins 1 and 2 of the AND gate chip. As you can see here, 1 and 2 are the inputs to the AND gate, while 3 is the output to the AND gate. So I connected the first wire to pin 2, and from pin 2 you can trace it to pin 1 of the AND chip. And another wire is connected to pin 4 of the NOT chip, and then you can trace it to pin 2 of the AND chip. Okay, so next I'm going to connect switch 1 to input A and switch 2 to input B. So as you can see, I connected a wire to switch 1. These are supposed to be down. Okay, I connected a wire to switch 1, and you can trace it all the way over here to pin 1, which is the input for the first inverter, also known as input A. On the diagram you can see input A is the input for the first inverter. Input B is the input for the second inverter. So I connected switch 2 to the input for the second inverter, which is pin number 3. Next, I'm going to connect output Z to an LED. So if we look in the diagram, output Z is the output of the AND gate. And the output of the AND gate, if we look at the chip diagram for the AND gate, the output for the AND gate is actually pin number 3. So from pin number 3 of the AND chip, I place a wire next to pin number 3, and then I connect it to an LED. In this case, I connected it to LED 0. Now we can begin to test the circuit. If we look at our truth table, we can see that we're supposed to begin by flipping switches, well, rather by having switches 1 and 2 both at 0. Switch 1 represents A and switch 2 represents input B. So we'll start with both switches down, both at 0. Oh. Sorry, that was the wrong page. Let's go back to, there we go, for figure 5.1. It's still the same thing. For the first switch we have A, and for the second switch we have B, input B. And so we're going to make sure that both switches are down. And both switches are down. Both switches 1 and 2 are down. So now I'm going to turn on the power. The LED is lit when I turn on the power. That means that for figure 5.1, I can put a 1, which is high. So I put a 1 for figure 1, which is high. Next, I need to make sure that one switch is flipped, not one switch, but I need to make sure that switch 1 is flipped down and switch B is flipped up. So switch 1 is down and switch 2 needs to be up. As you can see, the LED is no longer lit. That means that the result is low, or 0. So I place a 0 here. Now for the next one. Switch 1 is going to be high, or up, and switch 2 is going to be down, or low. So I flip switch 1 up, and I flip switch 2 down. And as we can see, the LED is not lit. This means that I need to write a 0 for figure 5.1 next to this situation. And finally, in the last situation, I have switch 1 high and switch 2 high. When I flip both switches 1 and 2 high, the LED is not lit in this situation either. So I put a 0 for this situation. For low. These results can be interpreted as the AND gate is basically functioning as an AND gate as it is supposed to. The AND gate will return a high output whenever two of its inputs, or rather whenever both of its inputs are high. However, In this case, we had an inverter at each of its inputs. We had an inverter at input A and an inverter at input B. As a result, by putting in a high at A and a high at B, we would get out a low at A and a low at B instead. And two lows in the AND gate will produce a low output. Also, likewise, when I put in a low at A and a low at B, the inverters invert it and it becomes a high at A and a high at B, in which case the AND gate will interpret this as a high output, or 1. And if we look at our results, this reflects this. Low, low produced a high. Low, high produced a low. High, low produced a low. And high, high produced a low because the highs were inverted into lows to produce a low output. And an AND gate will not produce a high output if both of its signals are not high. So the second and third situation don't work either. Next, I'm going to be constructing figure 5.2. As you can see, figure 5.2 is a NOR gate. A NOR gate is an OR gate with an inverter at the tip of it. This little circle at the tip of the NOR gate is the inverter. Rather, it represents inversion. Okay. So basically, I picked out the chip that has the NOR gates in it, and that is chip 7402. It's hard to see it with my camera, but maybe you can see that this chip is 7402. Pin number 14 is connected to power, VCC, and pin number 7 is connected to ground. Next, I need to connect input A to switch 1 and input B to switch 2. As you can see in the diagram here, it's actually a little different from the other gates. Input 1 is the output of the NOR gate, while input 2 is pin 1 is the output for the NOR gate, and pin 2 is input A for the NOR gate, and pin 3 is input B for the NOR gate. So I want input A. I want to connect switch 1 to input A, and so I'll connect a wire to pin 2. I'm going to connect a wire to pin number 2, and then from there I'm going to connect the wire to switch 1. Next, I'm going to connect input B to switch 2. Input B is pin number 3. As you can see, pin number 3 is input B. So I'm going to connect pin number 3 to switch number 2. Next, I'm going to connect output Z to an LED. We can see in figure 5.2 that output Z is the output for the NOR gate. And the output for the NOR gate, according to the diagram, the output for the NOR gate is pin 1. So I'm going to connect pin 1 to an LED. Here is pin 1. And here is the LED. I'm going to connect it to LED number 0. Now we're going to complete the truth table for the circuit. We're going to test the circuit for figure 5.2. The first situation is switch A down, switch B down. Switch A is switch 1 and switch B is switch 2. So switch 1 down and switch 2 down. As you can see, both switch 1 and switch 2 are down. Now let's turn on the power. The LED is on. This means that we can write a 1 for this situation. Situation 2. Switch 1 is down. Switch 2 is up. Switch 1 down. Switch 2 up. In this situation, the LED is not lit. This means that we write a 0. Situation 3. Switch 1 is down, switch 1 is up, switch 2 is down. So in this case, switch 1 should be up and switch 2 should be down. As we can see, the LED is not lit. This is another situation where we write a 0. The final situation is that switch 1 should be up and switch 2 should be up. Switch 1 up, switch 2 up. The LED is not lit. This is another 0. As we can see, figure 5.1, the situation in which we had the AND gate connected to the 2 inverters, is equivalent to the situation in figure 5.2, which was simply a NOR gate. So therefore, we have proven that a NOR gate can be represented with an AND gate and 2 inverters. Okay, next I'm going to construct figure 5.3. As we can see for figure 5.3, there's an OR gate. An OR gate is connected to 2 inverters, or 2 NOT gates. So for the NOT gates, I grab chip 7404 and place it on the farthest left end of my breadboard. So as you can see, hopefully, this is chip 7404. And next to it, I place chip 7432, which is the OR gate, the chip that has the OR gates. It's harder for me to show this on the camera, but this is chip 7432. Okay, Next, I need to connect my two NOT gates to my OR gates, to input A and input B of my OR gate. So as you can see, input A has a NOT gate and input B has a NOT gate, in which the output of the first NOT gate is going to be the input, the first input of the OR gate, and the output of the second NOT gate is going to be the second input of the OR gate. So, let's look at our diagram. Pin 2 of our NOT gate chip and pin 4 of our NOT gate chip are the outputs for the NOT gates. So I'm going to connect pin 2 of the NOT chip 7404, the NOT gate chip, to pin 1 of my OR gate chip. And I'm going to connect pin 4 of my NOT gate chip to pin 2 of my OR gate chip. So let's start with pin 2. I'm going to connect pin 2 to pin 1. Here's pin 2. Here's pin 1. Next, I connect pin 4 to pin 2. Here's pin 4, and here is pin 2. Next, I'm going to connect switch 1 to input A and switch 2 to input B. As you can see, input A is the input for the first inverter, and input B is the input for the second inverter, which means that input A is going to be pin 1, the input for the first inverter, and input B is going to be pin number 3, the input for the second inverter. So I'm going to connect pin 1 to switch 1. Pin number 1 of my inverter chip is going to be connected to switch 1. To switch 1, and pin number 3 of my inverter chip is going to be connected to switch number 2. There we go. Next, I'm going to connect output Z to an LED. Output Z, in this case, is the output of my OR gate. The output of my OR gate is pin number 3. So I'm going to connect pin number 3 of my OR gate chip to an LED. Pin number 3 of my OR gate chip is going to be connected to an LED. I'm going to connect it to LED 0. Okay, next I need to complete the truth table, or rather I need to test the circuit. So I'm going to start with the first situation. Remember that switch 1 is input A and switch 2 is input B. So I'm going to have switch 1 down and switch 2 down. Switch 1 down and switch 2 down. Now we turn on the power. The LED is not lit. Okay. That's actually wrong. That's not supposed to happen. So I need to find out why that's happening. Let me turn off my power and let me check all my connections. The reason that's not supposed to happen is because with an OR gate, it's supposed to produce a high whenever there's at least one high input. It produces a high output. And in this case, there are 2 inverters. So if I produce 2 inputs, if I put in 2 low inputs and the inverters are working, then it should be the same as putting in 2 high inputs. And when there are 2 high inputs, an OR gate will also produce a high output. That's why this result is wrong, and I need to check my circuit. So this wire is connected, but it looks like this wire is not all the way connected, so I need to push that in. Now let's try and see if this works. I'm turning on the power again. Okay, I don't know. I don't know what's going on. Okay, I found out what was going on. Basically, it was that my wire to the LED was not in all the way, or something. So, basically, again, I have... Well, let me actually put this back the way it was before. Okay, so again, I have 2 NOT gates connected to an OR gate. So the output for the first NOT gate is connected to the input for the OR gate, and the first input for the OR gate. And the output for the second NOT gate is connected to the second input of the OR gate. And the output of the OR gate, output Z, is connected to an LED, LED 0. And I have the input for the first NOT gate connected to switch the input for the first NOT gate is supposed to be connected to switch 1. Let me make sure I fix that. And the input for the second NOT gate is connected to switch 2. Let's connect that to switch 2. And hopefully we obtain the results that are expected, because these results are very much tested already. to be true. Okay, so when I make sure that switch 1 is down and switch 2 is down, switch 1 is down, switch 2 is down, and I turn on the power, bingo, the LED lights up, which means I can place a 1 next to this situation. So, the next situation, switch 1 is down and switch 2 is up. Switch 1 is down and switch 2 is up. The LED is still lit, so I can place a 1 here. The next situation, switch 1 is up and switch 2 is down. Switch 1 up, switch 2 down. The LED is still lit. This means that I can place a 1 for this situation. And our final situation, our final scenario is switch 1 down and switch 2 down. Switch 1 down and switch 2 down. Okay, I don't know what's going on again. The LED is not supposed to be lit here. Got to find out why that's happening. Found out why. The LEDs in this case are supposed to both be up. The last situation is that the switch 1 is up and switch 2 is up. Switch 1 up and switch 2 up. I'm not sure why I got that wrong. Anyway, the LED is not lit here. This means that I can place a 0 here. The next circuit for figure 5.4 has a NAND gate, which is an AND gate with an inverter. It's an inverted AND gate, a NAND gate. So the NAND gate is chip number 7400. Let's find that chip. Okay, I have placed chip 7400 to the position in the farthest left of my breadboard. And I've made sure that pin number 14 is connected to VCC power, and that pin number 7 is connected to ground. Now, next, I need to make sure that input A is connected to switch 1 and that input B is connected to switch 2. So if we look at our diagram, input A is pin 1, input B is pin 2. Let's connect input A, pin 1. Let's connect input A, pin 1 to switch number 1. And input B, pin 2, to switch number 2. There we go. Now, next, I need to connect output Z to an LED. So output Z is the output of the NAND gate. The output of the NAND gate, if we look at our diagram, is pin number 3. So I need to connect pin number 3 to an LED. I'm going to connect pin number 3. Here is pin number 3, right here. I'm going to connect it to LED 0. Now the circuit is ready for testing. Situation 1. Switch 1 is down, switch 2 is down. So let's make sure that switch 1 is down and switch 2 is down. Then turn on the power. The LED is lit. So we place a 1 for this situation. Situation 2 has switch 1 down and switch 2 up. Switch 1 down, switch 2 up. The LED is still lit. This means that we place a 1 for this situation. We write a 1 for this situation. Situation number 3, switch 1 is up and switch 2 is down. Switch 1 is up and switch 2 is down. The LED is still lit. This means that I write a 1 for this situation. And finally, situation 4. Switch 1 is up and switch 2 is up. Switch 1 up, switch 2 up. The LED is not lit. This means that I write a 0 for this situation. As we can see, the situations for the circuit for figure 5.3 and the circuit for figure 5.4 are the same. They are identical. This means that an NAND gate can be represented by an OR gate with 2 inverters. And that is all for this demo.